this is Madhu. Today I'll explain you how to find the best splitting attribute using information gain by solving an example. So let's get started. So I have taken this question in which I have given this data set and we will have to find the best splitting attribute using information gain. As you can see over here, there are 7 records and each record contains 5 attributes: ID, age, income, student and class, where class is our target attribute. The problem in front of us is that which attribute we should select as a splitting attribute. Either we can select age as our splitting attribute, or income as our splitting attribute, or student as our splitting attribute. Oh no, I have 3 choices. Which one I should go for? No worries. If there is a problem, there is a solution too. We will use information gain for selecting the splitting attribute by following these 3 steps. In the first step, we will calculate the entropy of the given dataset before splitting it. In the second step, we will calculate the information gain for each attribute individually. And in the very last step, we just select the attribute that maximizes the information gain. So, following the first step, in which we have to calculate the entropy of the dataset before splitting it. So we are given this dataset and let us assume that this dataset is denoted by S. So the entropy of the dataset S would be minus summation of probability of class label I log base 2 probability of class label I. In this dataset, we are having 2 class labels, yes and no. As you can see in the snapshot also, class label no, yes, no, no, yes, yes and no. So first we will find the probability of class label yes, which would be 3 by 7, as there are 3 records 1, 2 and 3 in which class label is having its value as yes and the total number of records are 7. And same for the probability for no, which would be 4 by 7, as there are 4 records 1, 2 and 3 and 4 where class attribute is having its value as no and the total number of records are 7. So the entropy of the dataset S would be minus probability of yes log base 2 probability of yes minus probability of no log base 2 probability of no. After that, I have just substituted these values over here and the entropy would be 0.98511. And we are done with the first step. Now move on to the second step, in which we have to calculate the information gain for each attribute. So what do we mean by the information gain? Information gain is nothing but it is a criteria which we can use to determine the goodness of a split. And this is the formula for calculating the information gain for an attribute. So let us try to understand this formula first. So information gain of an attribute A of a dataset S is nothing but the entropy of the dataset S before splitting it minus summation of entropy of the dataset where the attribute A is having its value as V multiplied by number of records where the attribute A is having its value V divided by the total number of records, where we can take the values that attribute A can have. So we will follow this formula in our question also. So we had 3 choices for splitting attribute. We had age, income and student. So first we will go for age. And the values that age can have are youth and senior. We can see over here youth, youth, senior, senior, senior and youth and youth. The number of records, and this is the contingency table, and this is denoting that the number of records is 2 when the class label is yes and the age is having its value as youth. As we can see, youth, no, no, we will not count it. Youth, yes, we will count it. So we are having 1. And again, youth, yes, we will count it 2. So we are having 2 records where the class label is yes and the age attribute is having its value as youth. And we will can calculate for no also. The number of records where the age is having its value as youth and class label as no is 2, as youth, no, and again here youth, no. And same goes for the senior also. Then I have calculated the entropy for youth, where this is the probability for yes, which is minus 2 by 4 log base 2, probability of yes, which would be 2 by 4, minus 2 by 4, which is probability of no, log base 2, again 2 by 4, which is probability of no, which would be 1. And one more thing which I want to tell over here is that this is the impurest split, because both the class level is equally distributed. We have equal distribution in both the class. So we know that entropy ranges between 0 to 1, and if it is having its value as 1, that is the highest impure split. And also I have calculated the entropy for senior in the same way. This is the main crux here, that information gain for the age attribute. So this is nothing but information gain of entropy of the data set before splitting it, minus this is the number of records where the age attribute is having its value as youth, and divided by the total number of records multiplied by entropy of the youth, minus the number of records where the age attribute is having its value as senior, divided by the total number of records multiplied by entropy of senior. So let's put all these values. So entropy of the data set is 0.9851, as I have already calculated it in the previous slide. And number of records for age is equals to youth is 4, as we will see here, 1, 2, 3 and 4. And the total number of records are 7, multiplied by entropy of youth is 1, as you can see over here, minus number of records where age is having its value as senior are 3, 1, 2 and 3. So 3, and the total number of records are 7 into entropy of senior. So this is this value, and after calculating this, we got 0.02016. So we will follow the same procedure for the income attribute also. As in the data set, this snapshot shows that income can have 3 values: high, low and medium. And this contingency table can be created in the same way as I told you earlier. So I have calculated entropy for high, entropy for low and entropy for medium. So information gain would be entropy of the data set before splitting it, minus cardinality of when income is high divided by the total number of records into entropy high, minus cardinality when income is equals to low divided by the total number of records into entropy of low, minus cardinality when income is equals to medium divided by the total number of records into entropy of medium. So entropy of the data set is again same, 0.9851, minus I haven't written the cardinality of this term because this would be 0 only, because entropy of high is 0. Again, as you can see over here, this is the purest split, we can say, because there is no record which belong to the yes class and having its income value as high. So entropy is 0 in this case, and income is, so we will move on to this. When income is low, the number of records when income attribute is having its value is low is 3, 1, 2 and 3, and the total number of records are 7 into the entropy of the low, which is 0.9182. I have calculated it over here, minus number of records where income is medium is 2, 1 and 2, and the total number of records are 7 into entropy of medium is 1. So this value would be 0.30587. And the same procedure goes for the student attribute also as well. And this value is 0.12802. And so the age attribute is having its information gain as 0.02016 and income 0.30587, and it is 0.12802 for the student also. And now we are done with the second step. So the third step was information gain. We will have to in the third step we will have to select the attribute that maximizes the information gain. So information gain of the income attribute is the highest amongst all. So this will be selected as a best splitting attribute. And now we are done. So thank you for watching this video. I hope I made myself clear and it would help you.